Hi guys, welcome to my channel. This is Iman Neo. As you might know, in this series we are implementing a color switch game replica, and in this episode we are going to implement some logics. For example, we can change the player's color, and we can implement a game over logic. For example, when you hit wrong color in the circle, you will lose, and these kind of things. So let's get started. At first, let's take a look at the latest state of the game. So we implemented a logic to jump, and we move the camera to follow the player when player moves upward. And also we have a circle rotator which has different colors in different sides, and it is rotating. So the next step is to add a logic to change the player's color. To do that, we need to define a new object. For example, we can call it color changer. And when our player hits the object, we need to implement a logic to change the player's color randomly. So to do that, I will create a color switcher dot. And here we can say last color extend. We can say a simple position component, and then we can draw our shape inside it. And we can create a constructor. We can get the position as a required variable. We can set the anchor as a center anchor. We need to define a radius, maybe. Define a variable here. Or maybe we can make it optional with a default variable of 10. Okay, and let's add this object in our game. As you remember, in our game we are adding ground, which is this icon or this finger icon. After that, we are adding the player, and also we have a function to add the circle rotator and other components of the game. So here we are going to add a color switcher object, and position can be this one with a little bit offset, for example maybe 200, and radius 10. The default is good. We don't change the default radius. Okay, as you know, we need to implement the render method to define the shape of our component. I will import .ui, and here we can say canvas draw circle, maybe offset is size divided by 2, because we are going to draw it at center. We can change it to offset because size is a vector 2, and we can divide a vector 2 because it is defined in here. We have some operators, for example plus, divide, scale, or minus. So here we say size divide by 2, and then we change it, we map it to offset, because canvas.drawCircle accepts offset. And we have radius, and in paint we can create a temp paint with color of red, maybe. Let me run the app again. Okay, as you see, we have our color switcher. Let me change the positions a little. We can move this one a little bit upward. Yes, 0 and 0 is good for circle rotator, and I can change it to something like 180. And okay, one important point is that in the player logic, we have hard coded the color. It is colors.yellow, and we need to define a variable here, uh, and we can set it as colors.white, for example, as a default variable, and we can set it here. This way we are able to change the player color using the code. So let's increase the radius to something like 30. It's too large. 20. Okay, I think 20 is good. Also, we need to decrease the player size. For example, 10 or 15 is good, I think. No, it's too large. 12. Yes, 12 is good. Okay, let's change the color switcher rendering. We can have a canvas draw arc. I want to make a shape of circle with different colors inside it. The available colors that we have, for example, here we can say size to rect, 0 to let's import math, and we can say use center tool and paint. Let's say green to see what happens if we nothing happened. If we uncomment, if we comment this code, oh, we don't have size here actually. We can say size is a vector to all is 0, radius times 2, I think. Okay, as you see, we have this shape. So we need to repeat this logic for other colors. Let me remove this one. And as you see, we have something like this. So to have access to the available colors which we defined in our game, we need to define a mix in here with uh, has game ref my game. And now we have access to the game. We can iterate over the game colors, traditional for loop with I variable starting from 0. Okay, this way we have access to the index because we need it. And here we can say that sweep angle is math.pi times 2, which is a full circle, and we can divide it by game colors.length. We can define it here and we can reuse it in this line. Okay, and now we need to implement this logic I times sweep angle, and here we can say sweep angle. And if I run the app, oh, we are setting this hard-coded color, which is wrong. We can say game colors of I index. Okay, so this is beautiful. And for example, if we add a new color, uh, you see that it adds a new section, and it divides the circle into it divides the circle to the length of colors. No matter how many colors do you have, using this logic, we are adding all available colors. So let's remove pink color here. Okay, the next step is to implement a logic to change the player's color when it hits the color switcher object. To do that, we need to use collision detection from the Flame game engine. So collision detection is an algorithm to detect when two components intersect or uh, collide with each other. And it is a complicated algorithm. You can implement it by yourself, but it does not make sense because you need to handle it efficiently. So Flame handles it for you out of the box, and you can use it. At first, you need to add this mixin to your game. Let's do that. My game. Okay, in this way we config the Flame game to handle the collision detections in the game. The next step is to add this mixin has collision detection. Sorry, this mixin collision callback to the components that you want to implement the collision behavior. For example, in our sample, we need to add it in both player and color switcher objects. And to do that, let me add it to the player and also color switcher. Okay. Uh, When you add this mixin, you can implement or override these two methods in your component. For example, in the player, we can override these two methods. Uh, and on collision called whenever you collide with another component. For example, when our player collide or hits the color switcher, this function gets called. And whenever your object detach or moves outside of the other component's boundary, on collision end calls. Let's add some prints here. We can say player dot and other, and here we can say on collision and just print other, and we can change it to debug print. Okay, and if you run the app, nothing happens. So to let the Flame know the boundary of each component, we need to add the hitbox. So hitbox is a shape which we define that in which area of our component Flame should handle the collision detection. For example, you might have a human body as a component, and you want to implement a collision detection for headshot. For example, you want to say if a bullet hits the head, player dies, or if it hits the body, player's health decreases. And to implement this logic, you can define different hitboxes for the player. For example, you can define a box for the head and a box for the other body, and you can define different logics to handle the when a bullet hits with the player. And for example, when it hits the head, you can kill the player because headshot happened, and if it hits the body, you can decrease the health. So in this case, we only have one hitbox because we don't want to implement something crazy like that. And yes, to do that, we need to also hitbox has different shapes. We have polygon hitbox, we have circle hitbox, we have rectangle hitbox. And for example, in both cases, we need to add a circle hitbox to the player and the color switcher. At first, let me enable the debug mode in the game to see the hitboxes areas. And in our player, I'm gonna increase the player radius temporarily to something like 50. And after that, I'm going to add a hitbox in unload method. Okay, and it needs radius. We can set radius by player radius. We can set anchor, which is anchor, and it can be a void. We can move it top. Okay, let me divide this radius by 2. Okay, as you see, this is the hitbox that we added to the player. So in the game, this player only detects the collision detections which happened to this area, not here, not here, not here. So this is the definition of hitbox. For example, we can different multiple hitboxes with different logics in our player. So now we only need a hitbox, which is player radius. It is covering the whole area of our player. And let me change it back to 12. I think it was 12. Okay, now we have collision detection in our player. Now Flame knows the area or boundary of our player. The next step is to do the same for color switcher. We can say unload. It's a void callback. We can move it here and we can say radius. Oh, I think we need to change the position to size by 2 maybe. Okay. And as you see, when the player hits the color switcher on collision is called with different values. What is this value? This is a set of points. These points are the intersection points of the player with the circle rotator. And also a collision end called whenever our player moves outside of the color switcher boundary. Okay, now I want to mention something important related to the hitboxes. Hitbox has a parameter called CollisionType. So CollisionType is an enum with different kind of values: inactive, passive, and active. So inactive is for when you want to disable or inactive the collision detection for a specific component. For example, in runtime, in a situation you want to disable this behavior, collision detection behavior, you make it inactive, and Flame works more performant because it does not calculate anything for the component that you make it inactive. And also we have passive and active collision types. These two are for when you have a different situation for different components. For example, in our case, our player should be active because it wants to detect collision with other components, and it is important for a player to receive all the collision detection. But our color switcher does not want to detect the collision with others. For example, suppose we have 10 color switcher objects in the game. Color switchers does not collide with each other, so it does not make sense in our game. Just player collides with the color switcher. So in this case, we can make the player active, and all the color switchers in our game should be passive because they don't want to collide with each other. They don't want to listen to the collision callbacks. And yes, to do that, we need to say CollisionType.passive to the color switcher, and we can say CollisionType.active to the player. I think this is the default. Okay, and when you hit the color switcher, you see that all callbacks are calling. And the most important thing is that we have instance of the object or component that the collision happened. For example, here when we print the collision, we have points that are intersection points of the collision, and also we have the position component, a type of the other component that the collision happened. For example, in this case, we can say if other is color switcher, we can handle the color change logic. And also we can remove this collision end because we don't want this callback. Okay, so here at first we need to remove the color switcher from the game because we collected it somehow. So we can say other remove from parent. And this way we are removing the color switcher that we hit from the parent. Yes, as you see, we remove the color switcher when we hit with the color switcher from the game or from the parent. So the next step is to implement a logic. For example, change color randomly. And we can say, do we have access to the game? Yes. Game ref dot game colors. Do we have random? Great. We have an extension in Flame, and it returns a random value of a list. We can say color equals to this new random variable. If we run the app again, you see that our player gets a new color. So let me remove the debug mode. Okay, now we have implemented the logic to change the player's color when player hits the color switcher. For example, we can add another color switcher to the game. We can say 0 and minus 50 maybe. And let me comment this section. Oh, a little bit more further up. 200. Okay, it is fine. And also we need to add another circle rotator with a different size. For example, 150 at minus 400 maybe. Okay, So now we have two different color switchers that our player can collide with them. The next step is to implement a game over logic. For example, when we hit the wrong color, we need to implement the game over logic. You lose when you hit the wrong color. And yes, to do that, we need to add hitbox to the different parts of the circle rotator. As you remember, we have circle arc in the circle rotator. So each section or each edge of a circle rotator is a circle arc component. So here we need to add a hitbox. As you know, we have circle hitbox, we have rectangle hitbox, but here it is a little bit different or difficult because we don't have a simple shape. We have an arc, so we need to add a polygon hitbox. So at first, let me simplify the issue. Let me disable the rotation, and after that, I will change it to one to only draw one part of the circle. Also, let's change the color to something like white, and also let me enable the debug mode in here. Okay, and also let me increase the thickness to something like 20. Now we need to work on a single part of the circle, and after that we can expand it to the others. Okay, it has vertices, and it is a list of vector 2. So here we can say vector 2, and for example we can say 100 and 100. Let's see, let's try with 50 and 50, and we can try with 150, and after that we can say 100 and 100, and let's see what happens. So as you see, it starts from 50 and 50, and it goes to 150 and 100 and 100, and then it gets back to the initial position. We can add more vertices here, for example 80 and 120, or maybe 50 and 111 and 110. Yeah, as you see, it is creating a polygon hitbox with different edges and different vertices. So we need to create a polygon to cover the shape that we are drawing. So to do that, we need a logic. For example, we can say, at first, let's define the center. Center is size divided by 2. And let me define a new function here to add hitbox. Okay, let's add some variables here. Start angle. We have the start angle, and we have the sweep angle. Let me define a precision, which is, for example, 4, and we can divide the sweep angle by precision -1. I will explain it to you shortly. Here we can say segment. So I'm dividing the length or the sweep angle of the arc with a precision value. For example, I hard-coded 4 value here, and after that I will create a for loop which iterates through mm, through the precision. Oh, this way. No, I lower than precision. Let me start with 0, and here we can have a list of vector2 vertices, and it is an empty list by default. And here we can add a vector2, which is a vector2 of x is math dot cosine of this let me define the segment. This segment start is segment times I. This segment is enough, and we can say math dot cosine of this segment, math dot sine of this segment, and let me run the code to see what happens. Okay, it is on top. At first, we need to multiply it with the radius because um, sine and cosine functions are working with something between 0 and 1. So we need to multiply it with the radius to have the exact value of the radius that we have. What is it? Okay, we don't have radius. We can define it. Radius is size divided by 2. Because it is a square, we are pretty sure that x and y variables are the same. And let me run the game. Okay, as you see, we have a polygon shape here, and I think we need to add the center here. Okay, as you see, the precision is 4, so we divided our shape with something precision -1 to have different segments of our sweep angle, and then we can add each point of segment to the polygon, and after that we add our hitbox to the shape. So in this way, for example, if we increase the precision to something like 8, we have a precise lines in the shape. If we decrease this to something like 6, as you see, we have some edges which are not exactly at the line of our arc. We can define a value that works in our game because we want to have an efficient game and a smooth game. That's why I define this value. Depends on the situation. You can have a different precision. For example, in our game, I think 6 is enough because, as you see, it detects the collision with the line, and it's okay. So and now I can run the app to see does player handle collision with the arc or not. I think I can add some prints in the player. Okay, here. Okay, as you see, it handles the collision with the shape. So I need to add something here because it is not exactly around the arc. We need to add more points to cover the inside of the arc. To do that, let me do something here. Okay, we need to add another for loop here to add the inner side of the arc points. For example, we can say instead of multiplying it with radius, we multiply it with radius minus stroke width. What was the stroke width? I think it was parent dot thickness. And if we run, okay, I think it is correct, but the order of points are not correct. As you know, we are adding points like these, and again, we are adding points like this. So we need to have a continuous line around the uh, arc. To fix that, we need to reverse the iteration here. Instead of in the first iteration, we are going from 0 to precision count, and here we need to do the reverse order because we go like this, and after that we go like this. So we need to start with precision -1 and I larger than 0, I minus 1. Okay, now we have a precise shape of hitbox around the arc. So we can increase it to something like 20. As you see, we have a very smooth shape behind it. And as you increase the precision, the algorithm gets slower. And it's better to have a lower precision to have a fast and a smooth game engine or game. And it is more efficient. For example, take a look at 5. You know, 5 is not really good, but if we change it to 6, it's good. Maybe we can change it to 8 to have a better precision here. Okay, and if we, as you see, when we hit the arc, the callback calls. Now we need to change back the code to have the different colors, to have the rotation. And also here we can make it passive collision because we don't want to handle collision between the arcs. You know, they are close to each other and they might have a lot of work with the collision detection because they're close together. So we make it passive. They don't collide with each other, and also the player collides with them. So it makes the game engine more efficient. Okay, so we need to revert back this code to add all the segments, and there is an issue here, I think. As you see, we have only one collision detection. Here we don't have anything, but here we have. What is the issue? Uh, oh, I think I realized the problem. We are not calculating or considering the start angle. We are only considering sweep angle. So to fix that, I think we need to add the start angle here. Okay, so it is working. Now we have different hitboxes around the arc, and each arc is a part of the circle rotator. So now we can modify our on collision logic of the player to say else if other is, what was the name of this component? Circle arc. Sorry. If other is circle arc, we can have a print state here, and we can say player collides with circle arc, and color is other dot color. And when we run the app, the yellow one has a yellow color. You see, different parts has different colors. So we can implement our logic here. We can say if this dot color or player color, what was that? Oh, it was private color is other dot color is not the other dot color. We can say print game over. And if we run the app, okay, so now our color is red, everything is fine. And when we hit the other colors, game over calls. For example, here, if we hit with the yellow, it's okay. And if we hit with other colors, game over calls. So here we can implement the game over logic. Let's remove the debug state, and also let's revert the thickness here to 8. And yes, so we have our game, and now we can implement the game over logic. We can define a game over function in the game because our game is responsible to handle the game state. When we want to pause, when we want to restart the game, when game over happens, or everything can be handled here. As a superclass of other components, we can say void game over. And in our player, we can say if our color is not the same as the arc, circle arc color, we can say game ref dot game over. At first, let me add a function. For example, here we are adding ground player and components. We can call it initialize game, and in initialize game we can have this code, and we can make it private. And okay, if we run the app again, nothing happens. And when you hit the run color, nothing happens. So we need to first of all destroy everything, and after that recreate the word again. We can say word dot children for each, and we can say element dot remove from parent. Okay, this way we are destroying the whole game. For example, when you hit the run color, everything is gone because we are removing everything. And after that, we need to call initialize game again. And if we run the game again, as you see, when you hit the run color, game resets from the initial to the initial state. So the point is that we are moving the camera, and also we need to reset the camera position to the 0 and 0. We can say camera move to 0 and 0 here in the initialize game method. And when you go up and when you lose, camera position resets to the initial position. Yes, everything is working well. Okay, I think we are done with this episode. Maybe in the future we can add some particles. For example, when you hit a wrong color, your player can be exploded to the screen, and after that we can add a sound effect or animation to make it more dramatic when you lose. So I think this is enough for this episode. Let me commit the changes. Okay, in the next episode, we are going to implement maybe some sound effects, background music, or something like that. Or if we have enough time, we can implement the pause menu or pause mechanic in the game. So thank you for watching my video. Don't forget to hit the like or subscribe if you like this series. And see you in the next episode. Stay tuned. Bye bye.